Today, I'll be showing you how to use Spillbox to allocate simultaneously running jobs to either your local machine or the cloud, based on the demand of the job. Here we have our workload manager Slurm. I have both a local machine and a second machine that is on the network. The weight of the second machine is set at 10. This means jobs will default to my local machine and only go to the network when all other machines are busy. Now, we'll reroute jobs from the second machine to instead go to the cloud using one simple method. All we need here is a wrapper script that tells the scheduler that if the chosen host is a gateway machine, the job should instead be sent to the cloud. With Spillbox, it's as easy as that to send peak demand to the cloud. Just prepend the line spill run to your command, and as easy as that, you'll be sending the jobs that have peak demand to the cloud and running average jobs locally. So to illustrate this is happening, we'll run a simple set of jobs using run.sh. All the script does is batch run a simple job called counter.sh that picks a random number, counts up to that number, and then prints the host name. We need the script to be available in the cloud. So first we'll use Spillbox to synchronize the data between on-prem and the cloud. So first I'll set up a Spillbox project. To do that, point to one of the clouds, Google or AWS. Then create a project. Creating a project will take a few minutes. While it does that, a quick aside. You can see the empty Slurm queue as we're running Slurm locally and on the cloud. However, you can also mix and match tools. You can run Slurm locally while running LSF or Kubernetes in the cloud, or vice versa. Run Slurm on the cloud while using LSF or Kubernetes locally. Now let me log into the cloud and see the machine we just created. So the Slurm worker node is the machine that was created. Now I'll take that IP address and use it to log in through Spillbox using SSH. Running SQ on the local machine, you can see that there is nothing in the queue. Now I'll run the script run.sh, which will submit 100 jobs of the script counter.sh that each count up to a randomized counter variable. First, we'll check top on the cloud machine and show there's nothing running there. So now let me submit all of the jobs. If we run SQ again, we can now see all the submitted jobs. Some have started running, some locally, denoted by Spillbox, and some in the cloud, which is denoted by worker01. I'll run top on the local machine now and see it has 4 counter.sh jobs running locally, while 1 counter.sh job runs on the cloud machine. To see the outputs for those jobs, we'll run ls-alrt locally. You can see the outputs printing. Now let's see how many jobs are completed using lsout.star pipe wc-l. So right now, 25 jobs are done in total. So let's check how many of those were executed locally, denoted Spillbox, using grep. We get 24. So let's just update that total completed number again. We get 37. So out of 37 jobs, 24 were executed locally, and the remaining 13 must be in the cloud. We can verify this again by looking at the full outputs. You can see the cloud IP address being printed by these jobs that completed on the cloud, and host Spillbox being printed by the jobs that completed locally. Let's update our numbers again. So now we're getting 36 done locally out of 56 completed jobs so far. There were 100 jobs, so it'll take a little while for all of them to complete. So for now, let's concatenate those previous commands and print both the completed total and the local total in series. So it looks like we're about 75 jobs completed, 48 of those locally. And again, you can see the counter.sh script running both locally and on the cloud machine. Let's check the queue again using SQ. Looks like there are only a few jobs left. So for our last update of the numbers, we have all 100 jobs completed, and out of that, 64 were executed locally, with the remaining 36 having been executed in the cloud. All of this was possible with one simple line prepended to our command, thanks to Spillbox.